All right, we're going to look a little bit more in detail at the mouth, pharynx, and esophagus in this video. So the mouth or oral cavity has the lips, also called labia, and then we have the labial frenulum, which are going to attach the lips to the gums. The oral vestibule, this is the actual opening of the mouth. Next up, we have the fauces. Um, kind of like faucets. Um, this is going to be the main part of the mouth, so kind of around the tongue and gums and stuff like that. The gingiva are the actual gums, and then we have the hard and soft palate forming the roof of the mouth, and then we have the palatoglossal and palatopharyngeal arches. These are going to be muscular folds that extend downward from the soft palate. This is on either side of the uvula, which is the little piece of tissue that hangs down in the back of your throat. And so these are going to be located very close to the tonsils, the palatine tonsils. So kind of looking at a graphic. So we've got the lips, we have the labial frenulum. Again, those little pieces of connective tissue that attach the lips to the gums. Sometimes these can be really, really tight and cause some issues. I've actually had my lower one cut because it was pulling on my gums too much. And so then we also have the lingual frenulum, which is connecting to the underside of the tongue. So issues with the lingual frenulum can lead to people being tongue-tied. And so that can also require some surgical intervention and stuff like that. So, hard palate is this more front portion of the roof of the mouth. The soft palate is further back, right before the uvula itself. And so now that we've got this graphic, here's the palatoglossal arch right here, kind of coming off of the soft palate. So that's going to be the structure, that fold in front of the palatine tonsils. And then the palatopharyngeal arch is the one that would be behind the palatine tonsils. And each person's going to have these being more or less visible depending on your specific anatomy and stuff like that. So they may not be super, super obvious like they are in this image. All right. Also important structure in the mouth is the tongue. This is going to help with ingestion, chemical and mechanical digestion, as well as sensation, speech, and swallowing. And so the tongue is really important for getting food into the proper position for chewing. It's going to help form the bolus, which is a kind of ball of food as we get ready to swallow it. And it's going to help position that bolus for the actual swallowing mechanism. So the bolus is what's traveling down the esophagus. There's a lot of very powerful skeletal muscle in the tongue, both intrinsic and extrinsic, so under different types of nervous system control. There are papillae all over it, which are hiding the taste buds, and again, it's anchored by that lingual frenulum. So here's that tongue. We have a bunch of those papilla. So we've got some different types there. And again, taste buds are going to be all over the tongue here. We have some special types of papilla towards the back, right before that lingual tonsil, which is not going to be visible really if you're trying to open your mouth and look at the back of your throat. You will see those palatine tonsils again, assuming you have not had them removed, but the lingual tonsil is going to be very difficult, if not impossible, to see. Next up are the salivary glands. We did cover these, at least their location in lab. We have the submandibular, sublingual, and then parotid glands. Their job is to secrete saliva. And saliva is really important for digestion. So we've got that parotid salivary gland. Submandibular is going to be under the mandible, and then the sublingual is going to be underneath the tongue. All right. And so these are all really important for that saliva production. Saliva is going to help kind of moisten the food that we're eating, which helps to start breaking it down, help start dissolving it. It's also going to contain certain enzymes like the amylase and lipases to start breaking down carbohydrates and lipids. And so these are all really, really important. So saliva is mostly water, it's 95% water, because we're just trying to get that water mixed in with the food. It can be either more serous, which is watery, to more mucus based or thicker. It's going to have not just water, but again, ions, enzymes, antibodies, and some growth factors. So, also having those antibodies for the immune system function. Most important enzyme is that amylase to start breaking down carbohydrates, and these are controlled by the autonomic nervous system, so that automatic division again. So, we also get some other things like lysozyme, which is not mentioned here, but that is really important for helping to create a antimicrobial property in saliva. Each of the glands has kind of a different mixture of things that it's going to secrete, so they're not all making the exact same things. And so the parotid glands, for example, will secrete a very watery solution that contains the amylase. Submandibular ones can have gland cells very similar to the parotid, plus some mucus secreting cells, and so the submandibular glands are going to contain amylase, but they're going to be a lot thicker. And then the sublingual glands are going to be mostly mucus cells, making the thickest saliva with the least amount of the amylase present in it. So each of them have their own makeup. So that's kind of why we need the three different types, because they're not all producing exactly the same thing. All right, next up are the teeth or dentes. We have 20 deciduous teeth, or baby teeth. So deciduous just refers to something that gets lost after a certain period of time. So a deciduous tree is one that is going to lose all of its leaves. In usually the fall or winter, and then regrow new ones in the spring and summer. And then humans get 32 permanent or adult teeth, 8 incisors, 4 cuspids, 8 premolars, and 12 molars. Not everybody's going to have 12 molars, but most people will, at least for a little while. So the permanent and deciduous teeth are going to look a little bit different. So the deciduous teeth, again, are only going to be present up until kind of early to mid childhood. It really depends on the person's genetics and stuff like that. So you can see over here in this graphic the different age ranges that we can expect to be replacing those particular teeth. So the deciduous teeth or baby teeth first start appearing usually around 6 months of age, and then between ages 6 and 12, they slowly get replaced by the 32 permanent teeth. And so we have just kind of that span of childhood where people are going to be losing teeth. So not everybody's going to lose the same teeth at the same ages. I was pretty late, personally, and didn't start losing teeth until towards the end of that range. That is genetic. My dad was the same way, and actually, I think still has one or two of his baby teeth. And I ended up having to have my remaining 6 deciduous teeth pulled when I was a junior in high school, believe it or not, because all of my permanent teeth were trying to come in behind it and it was getting really crowded. And so it was just a mess, and I needed braces for a long time and stuff. But my teeth are back in pretty good shape now. They're not perfect, but nobody's is unless they've got dentures and whether or not you want to consider those actual teeth is a whole separate conversation. So we've got these different teeth that come in slowly in early childhood, and then the permanent teeth start showing up in usually elementary school through maybe junior high-ish, depending on the exact teeth. And then that third molar, again, also known as the wisdom teeth, those are not going to come in on every single person. I miraculously have not had any of my wisdom teeth come in. Only the top ones are showing on x-rays at all, and they've not moved in probably about 15 years now. And then my bottom ones never actually showed up on x-rays, so not everybody ends up having those wisdom teeth come in. And a lot of people that do have them come in, it's too tight, and so they end up needing those to be removed and stuff like that. So a lot of you have probably had your wisdom teeth removed at some point or another. That's a very common dental procedure that's done. So teeth have some different components to them. They're not just like a bone or something. The crown is made up of enamel, and then there's the neck and root, which are both formed of dentine and a pulp cavity. And so this is what a cross section of a tooth would look like. So we've got that crown, that's the enamel. This is our protective coating on the outside of the tooth. Enamel is very strong, but it can still be cracked or broken and be damaged by other things. The dentin is this material right here in between the enamel and the actual pulp cavity. Dentin is a bone-like tissue. It's going to have that very strong property that bone does without actually being bone specifically. And so the dentin is still going to offer a lot of strength and stability to the tooth. And then that pulp cavity inside is going to contain the blood vessels and nerves of the particular tooth so that it stays healthy and stuff like that, because your teeth are still living things. And so the upper portion of the tooth can be cracked without any damage, but if you crack it too low, you do start exposing that pulp, and then it's going to be very uncomfortable. I have had that happen. It was not a pleasant experience. I don't recommend it. I've had a lot of dental issues. We don't need to get into all of them, but they're not fun. Take care of your teeth, y'all. All right, so we've got the root of the tooth. This is what goes not just into the gums, but into the jaw itself. So this is going to go anchor into the maxilla or mandible bones in the skull. They're held in place by a bunch of these little pieces of connective tissue. These are ligaments, and they're called periodontal ligaments. So they are, as ligaments do, attaching bone to bone. So they're anchored to that dentin and then to the bone in either the mandible or maxilla. So cavities would be a damage to that enamel that's gotten really deep into the dentin and into the actual pulp cavity itself. And then the gingiva or gums sits over the surface of the different bones, the maxilla and mandible, and are going to also be really important. You don't want a lot of stuff getting down here in between the tooth and the gums, obviously. So brush your teeth regularly, floss, mouthwash if you want to. Take care of your teeth. All right, next up is the pharynx. We've gone over this already with the digestive system. We'll briefly cover it again with respiratory, but the nasopharynx is important for respiration and speech. The oropharynx is important for respiration and digestion, as is the laryngopharynx further down. So there we've got our hard palate, soft palate, uvula. The nasopharynx is this region up here. So the entire pharynx is represented here in this kind of purplish color. Nasopharynx is up here by the nasal cavity, oropharynx back here behind the oral cavity, and then the laryngopharynx by that larynx again. So it is a passageway for air and for food and beverages and stuff like that. So there is going to be some skeletal muscle located here that's going to help with that swallowing mechanism as well as speech and stuff like that. So it is important to have some muscle in that particular structure. So the um, nasopharynx, again, part of that nose, is important for speech. Oropharynx and laryngopharynx are for breathing and digestion pretty much exclusively. That laryngopharynx is that last section before air would go into the larynx and trachea, and food and beverages are going to ideally stay in the esophagus because that epiglottis right here, this little piece of cartilage, is going to fold down over that opening and prevent food and beverages from entering the trachea. All right, next up is the esophagus itself. This is a muscular tube connecting the pharynx to stomach. The upper 2/3 are comprised of both skeletal and smooth muscles, so we do have some conscious control over that section. The lower third is exclusively smooth muscle, so we do not have control over that section. The esophagus is the start of that peristalsis movement, so moving that bolus of food from the mouth down to the stomach. And then we have both the upper and lower esophageal sphincters, and it is covered on the inside with non-keratinized stratified squamous epithelial with a lot of mucus secretion, and there is no serosa layer here, it's just that adventitia. So here's our esophagus. We do have an upper esophageal sphincter up here at the bottom of that laryngopharynx. And so that is why sometimes it can feel like food gets stuck in your throat, is because that sphincter is present there and it is controlling how much food can get sent down the esophagus at once, because swallowing large quantities of food at a time can be very uncomfortable and press on a lot of other structures and cause some issues. And so that upper esophageal sphincter is really important for slowly moving food through the esophagus. This is going to be under some conscious control. So we do have some of that smooth and skeletal muscle there. And then we have the lower esophageal sphincter, or the cardiac sphincter, that's controlling entrance from the esophagus into the stomach. And so we learned that in lab already. It's also sometimes called the gastroesophageal sphincter in some cases, but cardiac and lower esophageal are a little bit more common. The diaphragm surrounds that sphincter, and it is going to kind of signal that passageway between the upper portion of the digestive system and the lower portion. So swallowing or deglutition is voluntary. So we do have a largely voluntary swallowing reflex, but there are a couple other phases that are non-voluntary, so they're under that autonomic nervous system control. So autonomic means automatic. So the voluntary phase is under conscious control, and then we have the pharyngeal and esophageal phase. So that voluntary phase is going to happen in the mouth. The pharyngeal phase is going to happen in the pharynx, which obviously we've probably all been there. Once you swallow and it is past the reach of the tongue, there's nothing you can do anymore, really, unless you need to perform the Heimlich. And then even if something's not stuck, then the Heimlich may not necessarily be successful. The esophageal phase is obviously going to take place in the esophagus, and we don't really have control over that. So here is that upper portion, the voluntary phase of swallowing. So the bolus of food here is getting pushed by the tongue from the oral cavity into the pharynx. And then we have the bolus is kind of getting elongated here as it passes through the pharynx. this is where that upper esophageal sphincter would be located right here, controlling how quickly that enters the esophagus. And then it's going to pass down into the esophagus itself and be under control of that peristalsis until it reaches that lower esophageal sphincter further down. And we will wrap up here and continue in the next video with the stomach.